Okay, so this problem is really interesting because we have two different things going on. We've got the quadratic in nature. We also have two different trig functions. So you want to try first to transform to one trig function. So we're going to think about what our identities are. So those fundamental identities are going to tell us, well, I can't really change sine of 2x to anything, but I can change cosine squared of 2x in terms of sine of x. So I'm going to come off to the side over here and I'm just going to show you that. Sine squared of 2x plus cosine squared of 2x equals 1. So cosine squared of 2x is equal to 1 minus sine squared of 2x. We're not messing with the angle. The angle stays the same whether it's theta, whether it's x, whether it's 2x. That angle is fixed. So now I've got 1 minus 2, and in place of cosine squared of 2x, I have 1 minus sine squared of 2x. And then we have plus sine of 2x equals 0. I'm going to distribute the negative 2. And then we are going to combine any like terms and put it in quadratic form. So quadratic form is going to start with the quadratic term. So our sine squared will come first. So we have 2 sine squared of x. Then we have our linear term plus the sine of 2x. And then we have minus 1 equals 0 because 1 minus 2 is negative 1. I'm going to try and factor this. Now that I've set it equal to 0, we'll factor and we will try to use our zero product property. So how do we get back to 2 sine squared of 2x? Well, we've got 2 sine of 2x and we've got sine of 2x. How do we get back to negative 1? Well, that's easy. That's a positive 1 and a negative 1. And I want a positive middle term. So my positive 1 will go with the sine of 2x so that I have 2 sine of 2x. And then we have negative 1 sine of 2x, and negative 2 minus 1 is positive 1. So this works. Now we're going to take each variable factor, so each variable factor, and set it equal to 0. 2 sine of 2x minus 1 equals 0, and the sine of 2x plus 1 equals 0. I'm actually going to make a little bit of room here. Just spread out just a little. So this first equation, we're going to solve that. Sine of 2x equals 1/2. We'll add 1, divide by 2. And then we ask ourselves, where is the sine going to give us a ratio of 1/2? Well, that happens at our pi over 6 angles. And we have a pi over 6 angle in quadrant 1 and in quadrant 2 that gives us a positive 1/2 for sine. So we've got 2x equals, the angle equals pi over 6 plus 2n pi, and the angle also equals 5 pi over 6 plus 2n pi. We're going to multiply everything by 1/2. So multiply by 1/2, multiply by 1/2, and that's going to give us x equals pi over 12 plus n pi. The next one we multiply by 1/2, and we get x equals 5 pi over 12 plus n pi. And now because we needed to solve in the interval, I'm going to go way back up here. This is in the interval 0 to 2 pi. we need to substitute values in for n. Now, I'm going to also get a common denominator. So this is 12n pi over 12, so that it makes it a little bit easier for me when I put these values in. So I'm going to move this over a little bit. Like I'm going to just get that common denominator, 12n pi over 12. When I put a 0 in for n, x equals just pi over 12. When I put a 1 in for n, the second term is 12 pi over 12. So 1 pi over 12 plus 12 pi over 12 is 13 pi over 12. If I put a 2 in, I'm going to get a 24 pi over 12. So if I put a 2 in, 12 times 2 is 24. So we'll have 24 pi over 12 plus 1 pi over 12 is 25 pi over 12, but that exceeds 2 pi. So that is not an answer. Now we're going to do the same thing with this equation off to the right here. Not the right, but this one right here. So I'm going to put a 0 in for n, and I get 5 pi over 12. Then I'm going to put a 1 in for n, and I get 17 pi over 12. And then if I put a 2 in, I'm going to get 24 plus 5 is 29 pi over 12, which exceeds 2 pi. So that is not an answer. So this equation, I highlighted it in blue. This equation in blue gave us these answers, these 4 answers. Okay. Now we've got some more answers off to the right. We've got sine of 2x plus 1 equals 0. So that means the sine of 2x equals -1. We know that that happens in one place and one place only, and that's at 3 pi over 2 and every 2n pi thereafter. I'm going to solve for x by multiplying everything by 1/2. So 3 pi over 4 plus n pi. Now I need a common denominator, so I'm going to put 4 over 4. And then we have x equals, when we put a 0 in for n, we have 3 pi over 4. When we put a 1 in for n, we get 7 pi over 4. And if we put a 2 in for n, we already have exceeded. 8 pi over 4 plus 3 pi over 4 is 11 pi over 4. Therefore, and I'm going to color code this one too. So here are all the answers. So our answers are, I'm going to write them all out. Pi over 12, 13 pi over 12, 5 pi over 12, 17 pi over 12, 3 pi over 4, and 7 pi over 4. So those are all the answers to number 13. So that's a tricky one, and that would probably be like the trickiest one that you would need to do until we learn double angle formulas, which is in 5.5, I believe. This in a couple